Hey everyone, welcome to today's session on migrating databases to Amazon DocumentDB with MongoDB compatibility. My name is Meet Bagdev and I'm a Senior Product Manager on Amazon DocumentDB. And with me, I have Joseph Blair, a Senior Software Engineer at the Washington Post. We have a packed agenda for you, which will focus primarily on migrations to DocumentDB. But to kick things off with, we'll cover the basics around what DocumentDB is, talk about the common migration methods that we've seen our customers use, discuss some of the best practices. We'll also have a demo where I will show you how to migrate from MongoDB on EC2 to Amazon DocumentDB with minimal downtime. And lastly, we'll have Joseph talk about how they migrated MongoDB workloads to Amazon DocumentDB at the Washington Post. So let's kick things off. What is DocumentDB? So for folks who don't know, DocumentDB is a fully managed document database service in AWS that is MongoDB compatible. With DocumentDB, all your management tasks, database management tasks, such as patching, setting up high availability, security, are all taken care of for you by the service. DocumentDB is also highly scalable. Specifically, we have a unique architecture where compute and storage are decoupled. With this decoupled architecture, customers can scale out compute independently of storage. So for instance, customers can add additional read replicas with minimal, basically no downtime to their application. Customers can also scale up individual instances, so giving you the flexibility to both scale up and scale out. And moreover, storage on DocumentDB will scale automatically. So from up to 10 gigabytes to 64 terabytes, we will scale the storage as customers' workload on DocumentDB evolves. Lastly, we are MongoDB compatible, which means if you are running MongoDB today, you can continue to use the same tools and drivers that you use with MongoDB at scale on DocumentDB. We often get asked from our customers as to why our workloads or why are other customers moving to Amazon DocumentDB. And the first kind of reason here is because DocumentDB is a purpose-built operational JSON database. So if you're looking to store, index, and query JSON data, so if you model your data as JSON documents, DocumentDB is a database that's purpose-built for those kind of workloads. Secondly, with DocumentDB, customers get to use the flexible schema. So especially if you have a workload that's constantly evolving and you have the need to add additional fields to your data as time goes, with DocumentDB, you can do that easily. Users can define their own schema. Schema can evolve over time. With this flexibility makes DocumentDB a very appealing option for several of our customers. Thirdly, like I mentioned, we have a unique cloud-native architecture where storage and I/O will grow and scale automatically, giving customers the extra comfort, the extra benefit when it comes to storing their data that they're looking for from a cloud service. And last but not the least, with DocumentDB, customers often see a lower total cost of ownership, and you get the benefits of a cloud-based consumption billing model, which is quite appealing, especially if you're moving a workload from on-premises to the cloud. So let's jump into migrations, and before I dive deep into it, I wanted to kind of talk about what are some common sources of migrations. So the first one that I have here on the list is relational databases. And I actually call this out because it's actually not that uncommon to see customers moving from, let's say, Oracle or SQL Server to DocumentDB. Primarily, customers that are doing this are customers who are looking for schema flexibility, or they have noticed that the data that they were previously modeling as row and columns is actually more suited to the document data model. So that's kind of one primary source of migration. We've also seen customers migrate data from key value data stores. So specifically, customers are looking to do a little more indexing or query nested attributes, typically tend to move key value workloads to DocumentDB. Thirdly, this is the most common, is document data sources. So for instance, MongoDB workloads that are currently running on premises or on EC2 form majority of migrations on DocumentDB. Occasionally, we will also see a migration from Couchbase, and that's kind of what falls in this third bucket of document databases. And last, we have search. So we have seen customers migrate Elasticsearch databases to DocumentDB. And these are customers that have realized that they actually need a little bit more than just a search engine over their JSON data. When we talk about migrating to DocumentDB, and for the later part of this session, I'm going to focus specifically on migrating MongoDB workloads to DocumentDB because that's the most common pattern we see from our customers. There are several methods that customers have at their disposal. The first one is an offline migration. So with the offline migration, customers can use MongoDump and MongoRestore, which are native MongoDB command line tools, to create a logical database backup of their MongoDB source and migrate that over to DocumentDB using MongoRestore. This is a great option for customers looking to get started quickly, or if they're looking to do POCs. These tools are easy to download and easy to get started with. The second option here is online migrations. This is specifically for customers looking to do minimal downtime migrations. And for this, we use AWS service called the Database Migration Service, DMS, which will give customers the ability to go from a given source, which could be MongoDB, to DocumentDB with a fully managed experience with minimal downtime. This is ideal for customers who obviously have restrictions or would like to have the ability to run their source at the same time the migration is ongoing to make sure there's no downtime. One thing I want to call out is DMS actually supports a variety of sources. So let's say if you're going from Oracle or MySQL or PostgreSQL, DMS can support any of those sources to migrate data over to DocumentDB. DMS is also available for 6 months for free when migrating your workloads to Amazon DocumentDB. So let's dive a little bit deeper into each of the approaches. So to start things off, the first approach I talked about was the offline method. So if you're a customer looking to migrate your MongoDB workload to DocumentDB using the offline method, the first thing you'll do is you'll actually stop writing to your source MongoDB database from your application. So here, as you can see on your screen, you have your application. You'll essentially take downtime and you'll stop processing any new updates, inserts, or deletes to your MongoDB source. Once you do that, you will dump the data and indexes with MongoDump. MongoDump is the command line utility that I previously mentioned. Once you dump your indexes and data to an EC2 instance, you can then start your migration restore process to DocumentDB. First thing we recommend our customers to do is pre-create the indexes. So as you dumped your data, you can use the DocumentDB index tool to take the indexes from your MongoDB source and restore them to your DocumentDB cluster. This index tool is available on GitHub, and we highly recommend that customers pre-create their indexes instead of creating them after their migration, because if you do that after your migration, it's an operation of how much data you have. So if you have terabytes of data, creating your indexes after your migration or after you restore that data could take a really long time. So step 3, once you've created those indexes, you can use MongoRestore to restore that data onto DocumentDB. So once you've restored your indexes and restored your data, now you're ready to change the connection string from your application to point it to your Amazon DocumentDB cluster. So once you do that, your migration is complete and you're basically off and running. A couple of things I want to call out with the offline method is that this has the highest downtime. And by that I mean you basically cannot process any changes on your MongoDB source when you're doing your MongoDump and MongoRestore. That said, this is the simplest approach. If you're just trying to do this for a relatively small workload, or if you're just trying to do a POC this is quite handy, and you can get started with this and complete your migration pretty quickly. There are, like I mentioned, several customers and several use cases where downtime is actually not an option. You cannot afford to take your database down while you're migrating it to another database service. So for those customers, we have the online method, and the online method leverages DMS, the database migration service, heavily. So here's the difference in this method. So you still have the same application that we saw previously. This application continues to use the source database. So you don't take any downtime. You keep processing inserts, updates, and deletes to your MongoDB source. At the same time, you pre-create indexes from your MongoDB source onto your DocumentDB cluster. So you take essentially all the indexes using the DocumentDB index tool from the MongoDB source, and you restore those indexes onto DocumentDB. Once you've done that, you will spin up a DMS task. So database migration task essentially will connect to the source of your choice, which in this case is MongoDB, and essentially migrate all that data over to the target of your choice, which in this case is our Amazon DocumentDB cluster. With DMS, you have a few options. You can either do just a full load migration, but if you're looking to do a minimal downtime migration, you can choose a full load migration with CDC enabled. And what do we mean by CDC? CDC stands for Change Data Capture. And by this option, you will be able to replicate change events from your MongoDB source to your DocumentDB target. So for instance, as you're running your database migration task, you probably will have inserts, updates, or deletes continuing to process on your MongoDB source. These inserts, updates, and deletes will continue to keep getting replicated to your DocumentDB target as you use DMS. Then you can change the connection string from your application to point to your DocumentDB once you know that all the change events have successfully replicated over. We often see customers run DMS for a long period of time, and you essentially cut over, which is changing the connection string in your application when you feel like you've tested your workload out on DocumentDB and you're comfortable with doing so. So with this approach, you have minimal downtime. The only downtime you take is when you change your connection string. However, there is some complexity as you need to set up DMS. You need to it's a little more complex than the offline method. Moving on, so with both these options, there are some best practices that we often like to share with our customers. And the first one is verifying API compatibility. So DocumentDB is MongoDB compatible, but there are certain APIs that don't work on DocumentDB. So we highly suggest that our customers take stock of that and make note of those prior to their migration to avoid any surprises. Secondly, we highly suggest that customers size their clusters based on their needs. For instance, how many writes per second or reads per second do you need? What kind of memory do you expect DocumentDB to have? Or what's your CPU requirements? So we're happy to work with you if that's something you're looking to do. We're happy to work with you to help size your cluster, but that's something we suggest customers do prior to their migration as a best practice. Thirdly, this comes up more often than you think, is cost. As you're moving your database from one system to another system, there will be difference in cost. And it's important to estimate those costs prior to the migration. DocumentDB's pricing model is visible online, and there's a calculator as well that customers can use to kind of get a rough estimate of what it will cost to run their workload on DocumentDB. But just to avoid any surprises, highly recommend that you estimate your costs prior to the migration. Number 4, and I mentioned this a little bit before, is create your indexes before the migration. You can use the DocumentDB index tool. It's available on on GitHub. You can use the index tool to migrate all your indexes from your MongoDB source to DocumentDB. If you create them after the migration, depending on how much data you have, it can take a really long time. Number 5, it's important to size your op log, which is the operations log, to capture all the change events during the migration. So let's say if you expect your migration using DMS, which is the online method, to take 5 hours, it is important that the operations log can capture change events for those 5 hours. So if your op log is too small and it can only capture events for 3 hours, then you'll be missing the 2 hours worth of data. Number 6, for customers migrating large amounts of data or just customers who have sensitive perf requirements, we recommend that you scale up your primary instance at the time of the migration. So let's say if you expect the migration to take 6 hours, for those 6 hours, we suggest that you scale up your primary instance so it's able to handle the most write throughput, and that way speed up your migration. Once the migration is complete and you realize that you don't really need that much compute, you can scale your instance back down with a few clicks in the console. And again, if you're migrating large workloads, there's some parameters that you can tune. Specifically in DMS, you can actually parallelize your migration by specifying segments. So if you have, let's say, 10 records in your collection and you want DMS to load it across 3 segments, where the first one loads 3 documents, the second one loads 3 documents, and the third one loads 4 documents, you can specify these segments in DMS in the console or the CLI. Similarly, if you're using Mongo Restore, you can set a parameter called num insertion workers per collection, and this should typically match the number of vCPUs you have on your DocumentDB cluster to help parallelize the migration. And last, there is no substitute for testing. So even with all these best practices, there's really the only way for you to make sure your migration is successful is to test it out. So we suggest our customers to do this on a test workload before doing this on one of their production workloads. Everything that I talked about here is also available on our docs. You can see the functional differences with MongoDB and all the API differences with MongoDB, all on our docs. We also have migration guide published that you can take a look at if you're looking to migrate from MongoDB to DocumentDB. With that, moving on, so we have a demo for you. In this demo, we'll talk about how to migrate from MongoDB to DocumentDB with minimal downtime. So here I am. I'm connected to my MongoDB instance running on EC2. So this is just running in North Virginia in EC2. I'm running 4.0.9, and I have a few databases here. Admin, cases, config, and local. And the database I would like to migrate is cases. Inside this database, we have just one collection called daily_cases. And let's roughly see how many documents does this one have. So I'll quickly run a count. This document has collection has roughly 320,000 documents. And what we would like to do is migrate these documents over to DocumentDB using the the AWS Database Migration Service. This collection also has two indexes, one on the ID field and one on cases. In terms of the data, let's just quickly look and inspect one of the documents to see what the data looks like. And as you can see, it's just a few fields. The data set is essentially a data set about COVID cases, and as you can see, the index was on the cases field. Here in another window, I'm connecting to my DocumentDB cluster, specifically reInvent 2020 demo. On this DocumentDB cluster, I'm running DocumentDB 4.0, and if I do show databases, as you can see, I don't have any databases. So the first thing we're going to do is we're going to use the DocumentDB index tool to dump the indexes from our MongoDB source and restore them onto our DocumentDB target. So let's do that. And here I am in the index tool folder. You can clone the GitHub repository to get the index tool running locally on your client. And what we're going to do here is dump the indexes. So we just ran the DocumentDB index tool Python script, and as you can see, the option -- dump indexes. By doing this, we dumped the indexes to the ID folder, and specifically, as you see, once the indexes were dumped, we used another command called restore indexes, where we took the indexes from the index folder and restored it to our Amazon DocumentDB cluster. And as you can see, the two indexes that we saw earlier, _ID and cases, were restored. Let's quickly verify. So now if I go over back to DocumentDB, we actually do see a database. Inside that database, there's no data, so it shows 0 gigs. But if you do get indexes on our collection, you'll see that the two indexes that we had on our MongoDB source are now available on our DocumentDB target. So once you've dumped the indexes and restored them using the index tool, we will use DMS to migrate the data and to perform a minimal downtime migration. The first thing we'll do is we'll create a replication instance, which is essentially an EC2 instance that will take the data from your MongoDB source and restore them to your DocumentDB target. This replication instance should be in the same VPC as your DocumentDB target, because DocumentDB is a VPC-only service. So as you can see, our replication instance called MongoDB to DocDB is created. Once you create a replication instance, you need to create endpoints. And here we will create one source endpoint for our MongoDB 4.0 source. You'll pick the engine in DMS, which is MongoDB. You'll specify the server name, which is my EC2 host. Port name, I don't have SSL turned on this one, but I will for my DocumentDB cluster. Specify the username, specify the password, and we'll also give the database name that we want to migrate. So we wanted to migrate cases, so we added that. Once you add the required metadata, you can actually test your endpoint to make sure that DMS is actually able to read from your source. So we just ran a test, and it says the status is successful. So once you have successfully created your source endpoint, you'll do the same for your DocumentDB target. So you give your endpoint a name, you specify the engine type, you fetch the endpoint. So I'm getting the cluster endpoint for my DocumentDB cluster. I put in the endpoint, put in the port number. So for SSL, we do have SSL turned on by default. So when you do that, DMS will ask you for the certificate, which you can get from our documentation. So I uploaded the certificate required to connect with SSL. I specified username, password, and again, the database name is cases. We'll do a quick test to make sure that it's successfully set up. And there you go. So DMS is able to read from DocumentDB. And now you have two endpoints, a source endpoint and a target endpoint. And at this point, you're ready to create your tasks. So we're creating one migration task here to migrate all my data from MongoDB to DocumentDB. I choose the replication instance. I choose the source endpoint and the target endpoint. And for migration type, this is where you need to pick the type called migrate existing data and replicate ongoing changes. You can turn on CloudWatch logs. This will give you logging in case the task fails. You do need to add selection rules. I just like to leave wildcards here, which means it will migrate all the collections. But let's say you wanted to migrate specific collections, you can do that. And you have the option to start the task on create, which is what we'll do. So at this point, the migration task has started. And then as you see in a few seconds, the task has already started. And now if you jump over in a few seconds, you'll see that it will actually show you the number of records it migrated. So in our case, it migrated 320,341 documents. Now let's switch back over and connect to our DocumentDB target using the Mongo shell and verify that the data actually did successfully migrate. So I'm going to run a count. And as you can see, we had 0 documents before, and now we have 320,000 or so documents. So DMS, like I mentioned, can actually do a continuous replication as well. So any new inserts, updates, or deletes on your MongoDB source will continue to keep getting replicated to your DocumentDB target. So I'm back in my Mongo source. As you see, I have 320,341 documents. I'm going to insert another one. I'm just going to insert a simple x:1, simple single field document just for demo purposes. As you can see, the document was successfully inserted. And now, if I hop back here and actually try to do a find, let's see if I'm actually able to successfully find this document on my DocumentDB target. And there you go, we are able to. And this is because DMS actually migrated the new document that was inserted. If I just do a refresh here, you'll see the inserts column now shows 1 document. This means that after the full load of 320,342 documents, there was 1 document inserted after that. And you can essentially run both your source and target in parallel for an extended period of time, after which you can cut over based on your preference. So that's essentially how easy it is to migrate from MongoDB to DocumentDB using DMS. With that, I would like to introduce you to Joseph Blair from the Washington Post, who will talk about how they used DocumentDB, or how they use DocumentDB at the Washington Post.
Thanks, Meet. My name is Joseph Blair. I'm a senior software engineer with Arc Publishing at the Washington Post. And today I'm going to be talking about our experience migrating the WebSCED application to DocumentDB. So first, just some background on Arc. So Arc Publishing is a software as a service platform built by the Washington Post for managing digital experiences. It's built on a very modular architecture as an integrated ecosystem of cloud-based tools, each of which facilitates some step in the digital experience management process. So this includes things like creation and distribution of content, digital commerce, delivery, etc. We initially built it to meet the needs of the Washington Post newsroom, but saw an opportunity to license the software to external clients. And today we work with customers around the world. We've also expanded beyond just publishers to also support broadcasters and brands, and now Arc is available in the AWS marketplace. So like I said, I'm going to be talking specifically about the WebSCED application. So WebSCED is an editorial-facing planning, workflow, and curation tool. And editorial-facing in this context means that it's internal to our client organizations. And so our primary users are the employees of those organizations rather than the end users of their websites. And DocumentDB serves as the primary database that we use for many of the feature areas that we support in WebSCED. So this includes things like workflow and task coordination, which is basically a ticketing system for any workflows or tasks that need to be completed for your Arc content. This was designed for the copy editing process, but it's completely configurable, so any kind of workflow that you want to organize in WebSCED, you can set that up. We also support curation and budgeting, which is deciding which content is going to be featured on your end user-facing platforms and at what time. So this can include both 24/7 continuous kinds of platforms like a website or social media account, or more time-bucketed edition-based platforms like a print paper or newsletter. We also use DocumentDB to store various configuration data for the application. So one prominent use case that I'll call out is that you can subscribe to notifications for various events that occur within WebSCED. And all of this is stored in DocumentDB. So to provide some context on these screenshots, the first one is showing an example of the task search view for that first use case. And the second one is showing an example of the curation view for a sample newsletter for that second use case. We also support an editorial-facing content search, which is basically an internal view into all of your content stored in Arc, which includes both published and draft content. I've called this out on a separate slide because here DocumentDB serves in more of a secondary role in conjunction with Amazon's Elasticsearch service. So just a brief overview of our architecture. If you take a look at the labels on the bottom of the slide here, you can see that on the right-hand side we have the user-facing application. And this consists of an API that we've deployed using Docker containers and Amazon's Elastic Container Service, interacting with both of those databases that I mentioned. And then on top of that, we have a UI deployed using CloudFront, which is what most of our end users are interacting with. So then on the left-hand side, we have some infrastructure to support that content search use case that I mentioned. And this consists of another ECS service consuming updates off of Apache Kafka. And these updates come from upstream in the Arc platform, so basically from various other applications in the Arc ecosystem. And it's continuously pushing those updates onto both of our databases as an asynchronous background process. So since we have that ingestion process continuously writing to the database, you can imagine we have a pretty write-heavy workflow. So that's generating most of the IOs that you see here with a comparatively smaller number of reads. And then on the rest of the slide, we just have some additional figures about our scale on DocumentDB. So as far as the actual migration process, the most important prerequisite is to make sure that DocumentDB will fit the needs of your use case. So before we started on any of this, we had to do some small refactoring to address some of the discrepancies between DocumentDB and our previous Mongo setup. But once we had that taken care of, we were mostly working with the database migration service and change data capture as Meet demonstrated earlier. And this technology is really great because it allows for cutovers with minimal downtime or in many cases no downtime at all. Our use case though was a little bit more complicated because we have both the user-facing application and the ingestion process concurrently accessing our database. So in order to avoid any potential conflicts or overwritten data, we decided to pause that ingestion process for the duration of the cutover, but we were able to keep the user-facing application available the entire time. But since we paused that ingestion process, we decided to let our clients know ahead of time and take a pre-planned maintenance window. And then we staggered each of those deployments over the course of a few weeks just to make sure that there were no unforeseen issues before proceeding to the next environment. The actual cutover process itself, though, was pretty quick and seamless. It's really just a matter of redeploying your application with the new connection information. So in our case, that was redeploying those two ECS services, each of which took less than 10 minutes, but obviously that will depend on your specific application. So as far as the benefits that we've gotten from migrating, the biggest one is just the standard advantage of any managed service, which is that you get to offload a lot of those routine management and operational tasks. So things like patching and security and backups, you get to offload all of that to AWS and use their well-tested tooling. And this is great for us because it allows us to focus on development and delivering features for our customers. It also fit well for our use case because at Arc we're really big on infrastructure as code. So as best practices, we really emphasize managing our infrastructure in source control and deploying changes using continuous deployment pipelines. And so we already have processes and tooling built around those best practices. And DocumentDB fits seamlessly into this workflow because each cluster is just another CloudFormation resource. So we're able to define and manage it in the exact same way as all of our AWS infrastructure. Another thing that we were able to keep consistent is the vendor relationship that we have with AWS and access to the same support resources that we're already used to. So far we've had a pretty positive experience with DocumentDB, and particularly with database migration service and change data capture, the cutover process was pretty smooth. So that's all I have. Thanks for listening, and I'll pass it back to Meet to close things out.
Thank you, Joseph. And with that, it's a wrap. Thank you everyone who tuned in to watch our presentation today. I know you have a lot of options and a lot of sessions you could potentially watch, so appreciate you spending time and tuning in today. If you guys have any feedback, we'd love to hear. You can send your feedback over by completing a short survey. We look at this feedback very seriously, and if there's any content that you'd like us to cover in the future, that's something that you can also include in this survey. And with that, thank you everyone.